Hello students, welcome back. So students, we have been discussing the chapter rotational motion. Now let us start with the next module of the chapter rotational motion. Oh yes, this module is numericals based on angular momentum. Now students, in this module I am going to discuss one very important numerical that is based on the concept of angular momentum. So students, it's an important numerical. Are you ready? Fine. Let us move on to the module. First, let us take a look at the question. Okay, that's the question. So let me read it. A flywheel in the form of a disc rotating about an axis passing through its center and perpendicular to its plane loses 100 joule of energy when slowing down from 60 rpm to 30 rpm. Find its moment of inertia about the same axis and change in its angular momentum. Okay students, we have been following a procedure. Alright, the first thing is what we are going to write down. Yes, we are going to write down what are the given quantities. So students, tell me what are the given quantities. Yes, the first given quantity is the flywheel is losing 100 joule of energy. So delta E is given as 100 joule. Fine. What is the next given quantity? Yes, very good. It is slowing down from 60 rpm to 30 rpm. So we can write N1 is 60 rpm, N2 is 30 rpm. Now hold on, we need to convert this to RPS. So 60 rpm is nothing but 60 upon 60, which is 1 RPS. And what is 30 rpm? Yes, I heard you, very good. 30 rpm is 30 upon 60, which is half RPS, which is 0.5 RPS. Alright, so we have N1 and N2. Okay, any other quantity students? No, fine. What is the second step? Yes, second step is we are going to write down which quantity we need to find. Again, if you see the question, find its moment of inertia about the same axis. So I is asked, then change in its angular momentum, delta L is asked. Okay, so these are the two quantities that we need to find. What is the next step students? Yes, next step is your favorite one, the formulas. Now students, what formula can I use over here? Yes, good. First I can use the formula of kinetic energy of a rotating body. Kinetic energy is half I omega square. Then of course, for angular momentum, I know the angular momentum of a rotating body. Yes, angular momentum is I omega. So these two formulas I can use and I can get what is I and what is delta L. Okay, so let me carry this forward and let us move on to the solution part. Now first thing is, the students see there, change in energy is given. So we can write change in energy is final kinetic energy minus initial kinetic energy. Now see there, what is the formula for kinetic energy? Half I omega square. Alright, so we know omega is 2 pi n. So then kinetic energy will become half I into 2 pi n the whole square. Now this can be written as kinetic energy is half I 4 pi square n square. If you solve this, you'll get kinetic energy as I into 2 pi square n square. So you have the formula, the finals, it is a resolved formula for kinetic energy. So can you calculate change in kinetic energy? Yes. Using this formula, I can write delta E is nothing but 2 pi square n2 square minus 2 pi square n1 square into I. Is that clear? Fine. What is the next step? Next step is, you see that 2 pi square. It can be pulled out common. So you will get delta E is nothing but 2 pi square into n2 square minus n1 square into I. Is that clear? Fine. Next is, we need to calculate I. So what is I? I will be delta E upon 2 pi square into n2 square minus n1 square. Now students, we are coming very close to the answer. Now, you see there, I is equal to delta E. Is delta E given? Yes, delta E is given as 100 joule. Now, N1 and N2 is also given. N2 is 0.5 RPS, N1 is 1 RPS. So I can substitute delta E, N1 and N2 over there. So what I will get? I will get 100 upon 2 into pi, 3.14. So pi square is 3.14 square into 0.5 square minus 1 square. Is that clear? Now we have to solve this. So let us take this forward and we can find out what is I. Now I will be 100 upon 2 into minus 7.3947. Now hold on. Why there is this minus sign? Minus sign is there because this flywheel is losing some energy. Is that clear? So don't panic. Minus sign shows that the flywheel has lost some energy. So continue solving this. You will get I is 100 upon minus 14.7894. On solving it further, you will get I is equal to minus 6.7615. So we have calculated I as minus 6.7615. So the magnitude of I is nothing but 6.7615 kilogram meter square. Is that clear, students? Very simple. Alright. So now, the problem is not yet over. We need to find out what is delta L. So I'll carry this forward and let me go on to delta L. Now students, for delta L, first you see the formula. L is I omega. So I'm writing it L is I omega. Now I know omega is 2 pi n. So then L will become I into 2 pi n. This is the formula for L. Now students, what is delta L? Delta L is nothing but L2 minus L1. We know the formula for L, I into 2 pi n. So delta L will become 2 pi I into N2 minus N1. Yes or no? So now delta L is, now all the quantities are given. I, just now we calculated. If you take only the magnitude, it is 6.7615 kilogram meter square. And what is N2 and N1? N2 is 0.5 RPS, N1 is 1 RPS. You can substitute it over there. So let me substitute and let me solve it. I'll get delta L as minus 21.23 kilogram meter square per second. Again, minus sign shows it has lost some energy. So if you take only the magnitude of delta L is 21.23 kilogram meter square per second. Is that clear, students? It's a very simple module. Please be very careful. Minus sign here denoted that this particular flywheel has lost some energy. Okay? So continue revising. I'll catch you up in the next module. Until then, keep working. You can do it.